Practice exam questions, numbers 6, 7 and 8. So for question 6, we want to factorise our equations here. So if we look at this first one, we have A, B, B and C. We see we have B in both equations. We can take B out of that. AB squared is A times B, so we're left with AB. And BC is B times C, so here we're just left with C. So for number 2, we look at this and it's a little bit different. We've got here m squared and minus, and we notice, well, 4 is 2 squared and n squared there. So now we have squares on both sides and our difference of squares. So if we have m minus 2n multiplied by m plus 2n here. So m times m, m squared. Here we're going to have plus 2mn minus 2mn, so they cancel each other out. Then we've got negative 2 times positive 2 is negative 4n squared. Similarly, for the next question, we look at this and we say, okay, well, look, we've got an n and n. First, we're just going to take n out the front. Now we've got m squared minus 9n squared there. So we had 3, taken 1 out, we have 2 left. And we think, okay, well, 9 is 3 squared. So we have m squared minus 3 squared, n squared. And again, we have this difference of squares. So n, we're going to have m minus 3n, m plus 3n. Looking at question 7, we're simplifying our equations here. So for our first one here, we've got a to the power of 4, b squared, c in brackets, and we're cubing all of this. So remembering, when we're cubing, we're timesing. So here we're going to have a to the power of 4 times 3 is 12. B to the power of 2 times 3 is 6. And c to the power of 1 times 3 is c cubed. And in our denominator we have a squared, b, and c to the power of 4. So here we can cancel out. We've got 2, so a squared here, and we minus 2 there. We have b to the power of 6, and a b, we're going to minus 1. And here we've got c to the power of 3, here we've got c to the power of 4. We could minus 4 here and have a negative 1 and then move it down, or it's simpler to cancel out our c cubed and minus 3 here. So we're going to end up with a to the power of 10 multiplied by b to the power of 5, and our c is cancelled out here. At the bottom we have c 4 minus 3, and so we have all divided by c. So for question 2 is a similar sort of thing, and we just have to think through exactly what is meant by all of these things. So here we've got negative 2xy squared. We think it through, that's negative 2 squared, x squared, y squared, multiplied by 2, and here we're going to work through, here we've got x squared y all to the power of 3. So here x 2 times 3 is 6, and y 1 times 3 is 3. Here, and we've got here x cubed, y cubed. So here negative 2 squared gives us 4. Then we've got x squared, y squared, multiplied by 2, and here we've got x to the power of 6, y cubed, all divided by x cubed, y cubed. So we'll keep working through. We can multiply our whole numbers together. 4 times 2 gives us 8. And then remembering, when we're multiplying, we're adding them together. So x to the power of 6, we've got 6 x's in a row, and we're adding 2 more x's in our row. So here we've got 6 plus 2 is 8, and y to the power of 2 plus 3 gives us 5, all divided by x cubed, y cubed. So now we can go to our cancelling. Here we have x cubed at the bottom, minus 3, y cubed, and we're minusing 3. So we're ending up with this on 1. So we're getting 8, x to the power of 8 minus 3 gives us 5, y to the power of 5 minus 3 gives us 2, all divided by 1. So this just becomes 8 x to the power of 5 y squared. Okay, looking at question 8, we're wanting to express these as single fractions. So if we look at this first fraction here, we have AB at the bottom. Here we've got B squared. So here if we had, well, 2 on AB, we look at this, we can make, well, AB squared is what we can actually do. That will make this the same denominator. So to make this AB squared, we're going to multiply it by B on B. And then 3 on B squared. To make it AB squared, we need to multiply by A on A. So we're ending up with 2 times B on AB squared plus 3 times A on AB squared. Our denominators are the same, so we can just add our numerators. We have 2b plus 3a on AB squared. So similarly for our next question here, we think about this. This is our difference of squares, isn't it? X squared minus 2 squared. So this is an x minus 2, x plus 2. So here we're minusing 1 on x plus 2. So if we multiply that by x minus 2, then we're going to end up with this x squared minus 4 in our denominator, and we need to multiply by x minus 2 in our numerator as well. So it's the same as multiplying by 1. So from this we're getting here, we've got 2 on x squared minus 4 minus here 1 times x minus, and it's here 1 times minus 2. So x minus 2 there. And our numerator, we've got our x squared minus 4. Now it gets a little bit to the tricky part here. Our denominators are the same, so x squared minus 4 in our denominator. And now I like to use a bracket to make sure I don't get anything wrong here. I've got 2 minus, and this second part, x minus 2. So if we work this through, it's 2 minus x, negative times a negative is a positive, so plus 2 there on x squared minus 4. So here 2 plus 2 is 4 minus x on x squared minus 4. So looking at question 3 here, we're looking at a similar sort of thing. So here a squared minus b squared, and we've got a minus b. So if we multiply it by a plus b on a plus b here, we're going to end up with our difference of squares, and it will become a squared minus b squared. So we have 3a plus b on a squared minus b squared plus 1 times a is a, 1 times b is b on a squared minus b squared. Our denominators are the same, a squared minus b squared, so we put our numerators together. We have 3a plus b plus a plus b. So we have positive and positive, so it makes no difference if we put the brackets or not, but it's nice to have them so that we don't get confused. So we've got 3a plus a is 4a. We've got b plus b is 2b on a squared minus b squared there. Okay, looking at question 9 here. We're wanting to solve for x. So for our first question, what we want to do, we want to factorize. We've got a negative and a positive. So here, to get this, we know that we must have, here, there's our x terms, and we know, well, negative times a negative is a positive, so we know they both must be negative. And we've got to get to a final answer of 2. 2 times 1 is 2, and minus 1 minus 2 gives us minus 3. So here we know x must be equal to, x minus 1 is equal to 0, or here x minus 2 is equal to 0. So x minus 1, we add 1 and add 1. X is equal to 1. Add 2, x is equal to 2. Looking at question 2. So here we've got a positive and a negative. So we know, okay, well, to get a negative at the end, we must have a negative and a positive multiplied together to get that. If we had 2 negatives, it would become positive. If we had 2 positives, it would stay positive. So now we're looking at our 6, and we know, well, 1 times 6 is 6, and 2 times 3. We have 2 times 3, or 1 times 6. And so we're looking at this, we can either have this one, so here, if we had minus 6 plus 1, then we would get minus 5, but here if we have minus 1 plus 6, then we're going to end up with positive 5. So from this, we know, well, x minus 1 must equal 0, so x is equal to 1, or x plus 6 must be equal to 0, so x must be equal to negative 6. For number 3 here, we have a negative and a negative. So we know, well, to end up with a negative, we must have a negative and a positive. There. And we know, well, here to get to 8, 8 can be 8 times 1, or 8 can be 4 times 2. And we go, well, if we had negative 4 plus 2, we would get negative 2. So negative 4 plus 2. So we know x minus 4 is equal to 0, x is equal to 4, or x plus 2 is equal to 0, x is equal to negative 2.